Now, hello students, good morning. Now, today we are discussing about the transformer. Now, question says that why the transformer does not work on a DC supply system. This is a very important questions which is frequently asked in the examinations as well as in the competitive examinations also. So, in the given figure, I am showing the two different figures: a transformer uh, which is connected to the AC supply system here. And in this particular case, the supply voltage is alternating nature. Then the current is also is alternating in nature. Then the induced EMF will be created in a primary as well as in the secondary side with the help of uh, the flux. The flux will be equal to alternating in nature. This is the flux which will alternating in nature. So in this particular case, the induced EMF in any winding should be equal to minus n d phi by dt, where phi will be equal to phi m sine of omega t. Then you can substitute the value of phi in this particular equations. Then we will have a induced EMF in a primary as well as in the secondary side. That equation should be equal to E will be equal to 4.44 n phi m into f. बट द सेम ट्रांसफॉर्मर, यदि हम इसी ट्रांसफॉर्मर को डीसी सिस्टम पे वर्क कराते हैं तो व्हाट हैपन if you are giving the DC supply system, this is a positive and negative is here, this one a DC supply system is here, then the current is also in a DC system or DC current. Clear? Now DC current will create a DC flux, means a constant flux. This is a constant flux which is created by the current I1. If you are giving the DC supply to the primary winding, it is a constant flux will be there. Flux will be always created inside the core, है ना? तो कोर के अंदर जो फ्लक्स क्रिएट होगा वो आपका कांस्टेंट फ्लक्स होगा. दैट कांस्टेंट फ्लक्स शुड बी इक्वल टू, दिस इज phi m. I am indicated this is a constant flux is a phi m here, and the induced EMF in a primary winding as well as in the secondary side will be equal to E equal to n d phi by dt. Here the phi is a constant parameter. यदि आप कांस्टेंट का डेरिवेटिव करते हैं तो व्हाट हैपेंड, द इंड्यूस्ड विल बी इक्वल टू जीरो बिकॉज द डेरिवेटिव ऑफ द कांस्टेंट टर्म शुड बी इक्वल टू जीरो. तो डीसी सिस्टम पे ये ट्रांसफार्मर आपका वर्क नहीं करेगा. तो व्हाट इज द इंड्यूस्ड ईएमएफ इन अ प्राइमरी और सेकेंडरी वाइंडिंग? इट शुड बी इक्वल टू दिस, द प्राइमरी इंड्यूस्ड ईएमएफ इज इक्वल टू जीरो एंड सेकेंडरी इंड्यूस्ड ईएमएफ इज आल्सो इक्वल टू जीरो. Now the second question arises, what effect on transformer when DC supply system is given to the DC supply system is given to the transformer. तो AC जब सप्लाई पे AC कनेक्ट करते हैं ट्रांसफार्मर पर, तो what amount of current in the given circuit? This is the current which is delivered by the source V1 which is alternating in nature. So this is the amount of, because the induced EMF will be there. So what is the current in the given primary winding? I1 will be equal to, this should be equal to V1 minus E1 divided by Z1. Z1 is the impedance offered by the primary winding. It contains two different parameters R1 and X1. R1 is the primary winding resistance and X1 is the leakage winding reactance. ठीक है? जब हम इसको डीसी सप्लाई सिस्टम पे कनेक्ट करते हैं तो व्हाट हैपेंड, रेजिस्टेंस इज ऑलरेडी देयर. रेजिस्टेंस विल बी एक्टिव in both type of supply system AC and DC, but the leakage reactance X1 should be equal to 0 because the X will directly proportional to the supply frequency, because X is directly proportional to the supply frequency. The supply frequency of the DC system is a 0, so the reactance in a primary winding should be equal to 0, and 0 reactance will offer a short circuit. I am indicating a short circuit. Clear? Now, what amount of current, because there is no induced EMF in the primary winding, so what is the value of EMF? E1 will be equal to 0. Clear? Now, the substituting the value of E1 equal to 0 and the impedance of the primary winding is R1. So, what is the primary current? This is the primary current will be equal to I1 will be equal to V1 minus 0 divided by R1. So, that is the net amount of current will be flowing in the primary side is V1 upon R1. It should be very high because the impedance will be reduced and the numerator is also reduced. So denominator घट रहा है तो करंट की वैल्यू बढ़ रही है. न्यूमरेटर भी E1 V1 माइनस E1 भी रिड्यूस हो गया है बिकॉज E1 की वैल्यू 0 है. तो इसका जो आपका न्यूमरेटर भी घटा है और सॉरी न्यूमरेटर भी बढ़ा है, नॉट घटा है. न्यूमरेटर बढ़ गया है और डिनोमिनेटर आपका भी घट गया. तो इस दोनों की फैक्टर की वजह से करंट शुड बी वेरी हाई. करंट शुड बी वेरी हाई.